Okay, let's talk about AI, because something huge is happening right now. For years, we've basically thought of AI as a passive tool, right? Something that answers a question or makes a picture when we tell it to. But that's all changing. We're shifting away from those passive tools to something way more active, autonomous problem solvers we call AI agents. Let's really dig into what that means.
So to really get this, you got to see the difference side by side. On the one hand, you have the AI we're all used to. It's passive. It answers our questions. But the key thing is it needs us, a human, directing every single step. On the other hand, you have these new autonomous agents. They're active. They don't just answer questions, they achieve goals. And the most important part? They are self-directed. They figure out the next moves all on their own.
And this quote really nails it. You see, this isn't some crazy new thing that just appeared out of left field. Agents are the totally logical next step. They take the incredible reasoning power of a large language model and finally make it genuinely useful in the real world by giving it the power to actually do things.
All right, so how do these things actually work? To really get it, let's break one down. And honestly, the best way to think about it is like you're building a person. You got a brain, you got hands, and you need a nervous system to hook it all up.
First up, you've got the model. This is the brain. Simple as that. It's the core language model, the engine that does all the thinking, processing information, and, making the big decisions. This is where the planning and the reasoning happens.
But hey, a brain by itself can't do much, right? It needs a way to interact with the world. And that's where tools come in. These are the hands of the agent. They're the APIs, the code, the databases, anything that lets the agent's big brain actually take action. We're talking about things like searching Google, digging through a database, or shooting off an email.
Okay, so we have a brain and we have hands. Now we just need to connect them. That's the job of the orchestration layer. This is the nervous system. It's really the conductor of the whole orchestra, right? It runs the show, managing that constant loop of thinking and doing, handling memory, and deciding when it's time to think and when it's time to act.
So we've got the brain, the hands, the nervous system, we've got all the parts. Now let's see how they all work together. It all comes down to this really powerful, continuous cycle. And this is it, the think, act, observe loop. It sounds simple, but this is the secret sauce. First, the agent thinks. It looks at the goal and comes up with a plan. Then, it acts, picking a tool to get one step of that plan done. And finally, and this is key, it observes. What happened? Did it work? What's next? And it just keeps repeating that cycle, over and over until the job is done.
Let's make this super concrete. Let's say you ask it something simple. Hey, where's my order #12345? An agent doesn't just, magically know. It thinks. It creates a little plan. Step 1, okay, got to find that order in our database. Step 2, cool, got the tracking number. Now I'll use that to check the shipping carrier's API. Step 3, all right, I have the info. Now I'll put it all together into a clear answer for you. It's this methodical, step-by-step process.
Now what's really cool is that this basic setup, this think, act, observe loop, is just the beginning. It's the foundation. The real magic starts when we begin to scale this whole idea up and build way more powerful types of agents. And we can actually classify these agents into 4 main levels, where each level gets more and more capable. We start with the thinker, then move to the doer, level up to the strategist, and finally, the big one, we get to the team.
So at level 0, you've got the thinker. This is basically a brain in a jar. It's a powerful language model, but it has no tools, no connection to the outside world. It knows a ton from its training data, right? It could write you an essay on the history of the Yankees. But ask it the score of last night's game? Nope. It's completely blind to anything that's happened since it was trained.
So, level 1, that's the doer. Can use a simple tool to do one thing. But things get really interesting at level 2, the strategist. This is where agents can handle goals that are vague and have multiple steps. So if you ask it something tricky like, find a good coffee shop halfway between my place and my friend's place, it doesn't just guess, it builds a whole strategy. First, use a map tool to find the exact midpoint. Second, search that area for coffee shops, but also check their ratings. And third, present the best options back to you. See? It's planning.
And that brings us to the most advanced level, level 3, the team. This is where the whole game changes. We stop trying to build one single all-powerful super agent. Instead, we build a whole system of specialized agents that work together, just like a human team.
You've got a project manager agent that gets a huge goal, like launch this new product. It then breaks it down and delegates tasks to a market research agent, a copywriting agent, a code agent. You get the idea. It's basically mirroring how we work as humans, and that is just a massive leap.
Okay, this all sounds absolutely amazing, right? But here's the reality check. Taking this from a cool concept to something that actually works reliably in the real world, that is a huge challenge.
And here's the paradox, the fundamental problem we have to solve. The agent's single greatest strength, its amazing flexibility and ability to reason through new stuff, is also its biggest weakness. It's a headache. How do you take a system that's designed to be probabilistic and creative and force it to do one specific thing perfectly, reliably, every single time?
The answer is a whole new engineering discipline that's emerging called Agent Ops. You can think of it as the next step after DevOps and MLOps, but it's built from the ground up for this brand new world of unpredictable AI. It's all about bringing structure and discipline to these sometimes wild, complex systems.
Agent Ops gives us brand new tools for these brand new problems. Like, how do you even know if the agent is doing a good job? Well, one solution is to use another powerful AI as a kind of impartial judge to grade its work. It's literally like having one AI check another's homework. And what about when things go wrong? When an agent fails, you can't just check a log file. You need to use these super detailed traces to replay its entire chain of thought step by step so you can see exactly where its reasoning went off the rails. So when you pull all of this together, the basic building blocks, this evolution of capabilities, and now the discipline to actually manage it all, you get to a really profound shift in how we're going to think about work itself.
Because what we're talking about here, it's not just another flavor of workflow automation. This isn't just about making the same old processes a little bit faster.
No. The real takeaway here is that they are becoming new, capable members of the team. We are fundamentally shifting from a world where we use AI as a tool to a world where we collaborate with AI as a genuine partner. And that really leaves us with one big question to chew on. If you actually had a new teammate, an autonomous, capable, reliable AI teammate ready to get to work, what's the very first goal you would give it?
All right, let's get right into it. We're going to talk about one of the biggest challenges, and honestly, one of the biggest opportunities in AI right now. How do we actually connect these super smart models to the real world? This is all about something called agent tools and a new standard, MCP. So let's start with a really simple question, almost a silly one. We've got AIs that can ace log exams, write incredible code, so why on earth can't they do something as basic as order a pizza for you? Well, the answer is actually pretty straightforward. On its own, a large language model is totally disconnected from everything. It can't look up new information, it can't interact with an app, it can't take any action at all. It's incredibly brilliant, but it's completely trapped inside its own digital box. To really get this, we need to understand what we call the AI's walled garden. So, to break out of this garden, AIs need what we call tools. And a really great way to think about them is as the agent's eyes and hands. They're what allow the AI to see real-time info and actually do things in the world. But here's the thing. Connecting all these different tools to all these different AI models, well, it creates a massive technical headache. It's known as the N by M integration problem. Okay, so here's what that means. For every single new AI model, that's your N, developers have to build a totally custom connection for every single tool it needs to use. That's your M. As you can imagine, when you start adding more models and more tools, the number of these one-off connections just explodes. It becomes a developer's nightmare. It's slow, it's expensive, and frankly, it's just chaos. So how do we fix this mess? Well, the solution is like a universal key, a protocol called MCP. MCP, which stands for Model Context Protocol, showed up in 2024 to solve this exact problem. You can think of it as an open standard, basically a universal adapter. Its whole goal is to create one plug-and-play interface, a single type of plug that just fits every socket. And the way it's built is actually really simple and elegant. You've got the host, which is the AI app you're talking to. Inside that host is a client. That client talks to a server, and it's that server that holds all the tools and does all the cool stuff. And this is the absolute magic of it right here. MCP decouples the agent from the tools. The AI doesn't need to know all the messy, complicated details of how a tool actually works anymore. It just needs to know the tool exists and how to ask for it using this one standard protocol. This whole idea of decoupling, it opens the door to what a lot of people are calling a plug-and-play future for AI. And the advantages here are huge. I mean, development gets way, way faster. It creates a whole ecosystem of shareable tools, kind of like an app store for AI. And get this, agents can even find and learn to use new tools all by themselves, on the fly, making them way more powerful and autonomous. And this isn't just some quick fix. It actually lines up perfectly with these really forward-thinking ideas like the Agentic AI mesh. That's this concept where complex AI systems are built from independent, swappable parts. It's all about making our AI systems flexible and future-proof. Okay, but with all this incredible new power comes a whole new set of dangers. We have to talk about the hidden security traps. Because the second you give an AI eyes and hands to interact with the real world, you also create brand new ways for things to go horribly wrong. A whole new threat landscape just appears out of nowhere. One of the sneakiest risks is something called tool shadowing. Just look at these two tool descriptions. On the left, you've got a legit secure tool with super specific instructions. But on the right, that's a malicious tool. Its description is deliberately vague and broad. It's literally designed to trick the AI. So, when the AI is faced with these two choices, it could easily get confused and pick the malicious one, thinking it's just being helpful. And the result? Your sensitive data gets sent straight to an attacker's server instead of your company's secure vault. This might sound like a new AI problem, but it's actually a modern spin on a classic security flaw that's been around for decades. It's called the confused deputy problem. The AI becomes the confused deputy, a program with a lot of power that gets tricked into misusing it by an attacker with very little power. So here's how the heist goes down, step by step. First, an attacker with zero privileges gives the AI a malicious prompt, something like, find the secret key file and move it. The AI, our confused deputy, sees what looks like a valid command and just passes it along to the super powerful MCP server. Now here's the critical flaw. The server only checks its own permissions, which are high. It doesn't check the permissions of the original user, so it executes the command, and just like that, the attacker has completely bypassed security. Okay, so that's pretty scary, right? The critical question then becomes, how in the world do we build a secure agent in this new environment? Well, here's the catch. MCP was designed for open, decentralized innovation, which is great. But it means it doesn't come with things like enterprise-grade security or identity management built right in. That responsibility, it falls squarely on the people and companies who decide to use it. But the good news is we have a clear playbook. To stop rogue tools from being added, you use a strict allow list. To stop tool shadowing, you make sure tool names can't overlap, and you force a human to say yes for risky actions. And to defeat those confused deputy attacks, you have to enforce the principle of least privilege, meaning you always check the original user's credentials, not just the server's. It really all comes down to this. MCP gives us the standard, right? The common language for AIs and tools to talk. But it's the enterprise, the organization using it, that absolutely has to build the secure, auditable fortress around that conversation. Which leaves us with one final and really crucial question. The protocol provides the connection, giving our AI incredible power. But that forces us to ask, who ultimately provides the protection? You ever wonder how some AI assistants seem to, know you? They remember stuff from past conversations, while others feel like you're starting from scratch every single time. Well, that personal touch, it's not magic, not at all. It's a really cool discipline called context engineering. And today, we're going to break down exactly how it works. All right, let's get right into it. We've all been there, haven't we? You pour your heart out to a chatbot, tell it all your preferences, and then the next time you talk, it has total amnesia. It's like, who are you again? So frustrating. Why does that happen? Well, the answer comes down to one single, really critical fact. At their very core, large language models are what we call stateless. I know, it sounds a little technical, but all it really means is they're designed with absolutely no built-in memory of what's happened before. And this right here, this creates what you could call the AI amnesia problem. This whole stateless thing is the fundamental hurdle, the big challenge developers have to get over to build AI agents that actually feel smart and personal, instead of just being a super powerful but incredibly forgetful calculator. So, what does stateless actually mean in practice? Think about it like this. An LLM's entire world, its whole awareness, is stuck inside the one single message you just sent it. The second that interaction is done, poof, its memory's wiped completely clean. Without some extra help, it has no idea what you said 5 minutes ago, forget about last week. Okay, so if the model has no memory of its own, how in the world do we fix this amnesia problem? The answer is, we have to engineer a memory for it. And that is where we get into the solution, this really powerful practice known as context engineering. And this is honestly the best way to picture it. Think about a master chef getting their mise en place ready. That's that critical step where they gather everything, chop it all up, and organize every single ingredient before they even think about turning on the stove. Well, context engineering is basically the mise en place for an AI. It's all about getting the right information ready to go before you ask the model to cook up a response. So, okay, here's the more formal definition. Context engineering is the process of dynamically assembling and managing all the information the AI needs. And I mean all of it. Past conversations, your preferences, maybe some external documents, and then packing all of that into the LLM's context window for every single turn of the conversation. It's a constant, active process that happens over and over again. And this whole process runs in a continuous 4-step loop. So for every single message you send, first, the system fetches all the relevant context. Step 2, it prepares and assembles all that stuff into one big state-aware prompt. Third, it actually calls the LLM to generate the response. And finally, and this is key, it uploads any new information from that chat back into storage so it's ready for next time. So how does this all actually work under the hood? Well, it really comes down to 2 core components. Let's start with the first one, which is kind of like the agent's short-term memory system, the session. Okay, the absolute best way to think about a session is like a temporary workbench you'd set up for a single project. You've got all your immediate notes, your tools, your materials right there, super easy to access. It's perfect for what you're doing right now, but it's also temporary and, probably a little messy. So, technically speaking, a session is just a container that holds the history of one single continuous conversation. It's the play-by-play, the chronological log of what's been said, plus a little scratch pad for the agent's working memory. This is what lets an AI remember what you literally just said 2 sentences ago. But, a workbench isn't enough for the long haul, right? When the project is over, you can't just leave everything out. You need a system for permanent storage. And that's where our second core component comes in, memory. So, if the session is our temporary workbench, then memory is the organized, long-term filing cabinet. Think about it. You wouldn't just shove your entire messy workbench into a closet. No way. You'd go through everything, toss out the rough drafts, and carefully file away only the most critical, important stuff into nicely labeled folders. And that is precisely the job of memory. It's the mechanism for long-term persistence. It captures the key facts and insights from all your different sessions and consolidates them. This is how an agent can start to feel like a real partner, remembering your big career goals or that favorite vacation spot you mentioned months ago. Pretty cool, right? Now, I know what some of you might be thinking, especially if you're familiar with the AI space. You're probably saying, hang on, this sounds a lot like another popular technique I've heard of. And you know what? That's a great question, because the distinction here is absolutely vital. So, is memory just a fancy name for retrieval augmented generation, or RAG, the technique for pulling in external documents to answer questions? The answer is a big, clear no. They actually serve 2 very different, though, sometimes complementary, purposes. The most helpful way I've found to see the difference is to think of them as 2 different people with 2 different jobs. Think of RAG as the agent's research librarian. Memory, on the other hand, that's its personal assistant. And this breakdown really hits the nail on the head. The librarian, RAG, its job is to go consult a huge library of static external documents. Think wikis, textbooks, to give you authoritative facts about the world. But the personal assistant, Memory, its job is to keep a private dynamic notebook just about you, learning from your actual conversations. So let's put it this way. RAG makes an agent an expert on the world's facts. Memory makes an agent an expert on you. All right, let's bring this all home. When you combine these two things, the temporary workbench of sessions and that long-term filing cabinet of memory, you can finally solve the amnesia problem. You can build genuinely stateful AI. So, let's just do a quick recap. We started with the big problem, AI amnesia, all because LLMs are stateless. The solution? Context engineering, which is like creating that perfect mise en place of information. We saw how it uses sessions as a temporary workbench and memory as a long-term filing cabinet. And most importantly, we learned that RAG makes an agent an expert on the world, while memory makes it an expert on you. I want to leave you with this one last thought. By giving AI the ability to remember, we're doing more than just making a smart tool. We're setting the stage for something bigger. The next generation of AI won't just be smart, it'll be wise. And as this quote so perfectly puts it, true wisdom that always begins with memory. So we're in this new world, right? AI is moving beyond being just a smart tool. It's becoming an agent. It can plan, it can act all on its own. Now that is incredibly powerful, but it also opens up this huge can of worms. These agents are, by their very nature, unpredictable. So the big question is, how on earth do we build AI that we can actually trust to make the right call every single time? To really get a handle on this, let's try an analogy. Picture this. We're in a kitchen. And this, right here, this really gets to the absolute heart of the problem. Think about traditional software. It's like a line cook. They've got a recipe card, it's laminated, they follow the steps, bang, done. It's predictable. You can just check off a list to see if they did it right. But an AI agent? Oh no. That's a gourmet chef who's been thrown into a mystery box challenge. You give it a goal, a few ingredients, and it literally invents a new recipe from scratch every single time. You just can't use a simple checklist for a genius chef. And that's exactly why our old ways of testing software just completely fall apart here. So what this does is it forces this huge fundamental shift in how we even think about quality. We're moving away from what you'd call verification, which is just, did we follow the recipe, to validation, which is asking, is the final dish we created actually any good? And you have to get this because AI agents don't fail by crashing your computer. They fail in these really subtle, almost spooky ways, with things like factual hallucinations or just flawed logic that can quietly destroy trust and cause some serious real-world problems. Okay, so if a simple pass-fail test is totally off the table, how do we define what a good AI chef even looks like? How can we tell if it's consistently whipping up Michelin star quality solutions, or if it's just making stuff that looks plausible but is actually a complete mess? We need a whole new playbook, a completely different way of looking at this. We need a scorecard that doesn't just grade the final result, but actually digs in and evaluates the quality of the agent's thinking process, step by step. And that scorecard, it's built on these 4 core pillars. First up, effectiveness. Super simple. Did it actually do the thing the user wanted? Second, efficiency. Okay, great, it worked, but did it take 25 ridiculous steps and burn a ton of cash on tokens to get there? Third, robustness. What happens when the real world gets messy? An API call fails, or the user gives it a confusing prompt. Does it just throw its hands up and quit, or does it adapt? And finally, the big one, the absolute non-negotiable, safety. Is it staying within the guardrails we set for it, ethically and securely? See, a truly high-quality agent has to nail all 4 of these, not just 1 or 2. But here's the real kicker. You simply cannot measure these things if you're only looking at the final answer. You have to get under the hood and see how the sausage gets made. We have to make this shift from a black box view, where we're basically just tasting the final dish, to a glass box view, where we can watch the entire cooking process from start to finish. The black box just tells us if it worked. The glass box, that's what tells us why it worked or why it failed. And that why is where all the important learning happens. And this leads us to a really critical insight, a kind of mantra for this whole thing. The single source of truth for an agent's quality isn't the output. It's the entire journey it took to get there. It's what we call the trajectory. So what is a trajectory? Well, it's basically the agent's chain of thought, but made visible, so we can inspect it. It's the full play-by-play of its internal logic. Here's what I thought, so here's the action I took, here's what I observed as a result, and here's my next thought. By analyzing this whole path, we can pinpoint exactly where things went right or wrong. Was it a bad plan from the get-go? Did it use a tool the wrong way? Or did it just completely misinterpret the data it got back? But to actually see this trajectory, you can't just wish for it. You need the right set of tools. And that brings us to this idea of observability. Think of it as the toolkit our food critic needs to do their job properly. Observability really boils down to three main things. First, you've got logs. These are like the agent's diary, just raw, time-stamped notes of every single thing that happened. Then you have traces. Traces are what connect all those diary entries into a story that actually makes sense, showing you the why behind the what. And finally, you have metrics. That's the scorecard, the final star rating that gives you that high-level, at-a-glance view of how your agent is doing over time. But it's important to know that not all metrics are the same. We have to track two very different kinds. On one hand, you have system metrics. Think of these as the agent's vital signs, things like speed, cost, how often it runs into an error. But then you have the much trickier but arguably more important quality metrics. These are the ones that actually measure the quality of its judgment. Was its answer correct? Was it helpful? Was it safe? And getting these scores, that's hard. It often takes a sophisticated human, or sometimes even another powerful AI, to step in and act as the judge. So, the million-dollar question: how do we put all these pieces together? The 4 pillars, the trajectory analysis, the observability. How do we build a system that doesn't just work once, but gets better and better and better over time? Well, the answer is this really cool concept called the agent quality flywheel. It's a virtuous cycle. First, you define what quality even means using those 4 pillars. Second, you instrument your agent so you can actually see what it's doing. Third, you evaluate that process using a mix of automated AI judges and human experts. And then, here's the magic, the 4th step is you build a feedback loop where every single failure automatically gets turned into a new test case for the future. So every mistake literally makes the system smarter, which spins the flywheel faster and drives this relentless cycle of improvement. When you boil it all down, it really comes back to 3 foundational principles. Number 1, quality can't be an afterthought, something you check for at the end. It has to be baked into the agent's architecture from day 1. Number 2, the final answer is just the last page of the book. The whole story, the trajectory, is the truth. And number 3, while AI can help us grade things at scale, at the end of the day, we the humans are the ones who write the rubric. We are the ultimate arbiters of what good actually means. So ultimately, building trust in AI, it's not magic, and it definitely can't be based on just hoping for the best. It has to be a rigorous, data-driven engineering discipline. As these autonomous systems become a bigger and bigger part of our lives, figuring out how to build, measure, and validate that trust might just be one of the most important challenges of our time. The real question is, are we ready to build it? Welcome to the Explainer. Today, we are diving into the journey of an AI agent. And trust me, it's a journey that's way harder than it looks. We're talking about how you get from a cool little demo all the way to a product that a business can actually depend on. We're going to map out all the hidden challenges along the way. You know, this one sentence from the prototype to production white paper, it just nails it, right? Anyone can hack together a prototype agent in a weekend, but building one that you can actually trust with your company's data, your customers, your money, well, that is a completely different ballgame. Because if you skip the hard part, the trust part, the consequences can be, well, catastrophic. We're not talking about small bugs. We're talking about an agent being tricked into giving away your products for free, a user getting into a confidential database, or a key system just stopping. Dead. These are serious business-level risks. And this whole problem has a name. It's called the prototype to production gap. It's that feeling that you're almost done, but that last 10% of the work turns into 80% of the effort. It's the massive gulf between a cool tech demo and a system you can actually bet your business on. And that 80% number, it's not an exaggeration. Think about that. 80% of your time and effort isn't spent making the agent smarter in the way you might think. Nope, it's spent on all the stuff around it. The infrastructure, the security, the endless testing and validation. That's where the real work is. Okay, so how do you do it? How do you build that confidence before your agent ever sees a real customer? How do you go from just hoping it works to knowing it works? Well, it all starts with one single foundational principle. And that principle is called evaluation-gated deployment. The name might sound a little technical, but the idea is incredibly simple and powerful. It just means that no new version of your agent gets to see the light of day, no users, no production, until it passes a whole series of tests that prove it's safe and effective. It's your ultimate quality gate. So how do you enforce this? With an automated pipeline that acts like a funnel. Right at the top, you have fast, cheap checks that run before any code even gets merged. If it passes that, it moves down to a staging environment for more intense testing. And only if it passes all of that does it get to the final gate where a human gives the final okay for production. It's all about catching problems early. All right, so your agent made it through the funnel and it's live. Job done, right? Not even close. In many ways, the real work is just getting started. Managing a live, autonomous system is a whole different beast than managing traditional software. You need a continuous loop to manage it, and that loop starts with one thing: observe. You have to be able to see exactly what your agent is doing in the wild. Think of logs, traces, and metrics as its sensory system. It's how you get a clear, data-driven picture of its behavior, moment to moment. Okay, so you're observing. You're seeing what's happening. What's next? You act. These are your operational levers, the things you can pull in real time to manage performance, keep costs in check, or respond to a threat. This isn't about making the agent smarter tomorrow. This is about keeping the system healthy and safe right now. And that brings us to the final and maybe most important piece of the loop: evolve. This is where you take everything you've learned from observing production and you feed it back into the system to make permanent improvements. And this creates this amazing, virtuous cycle where your agent is constantly getting smarter, safer, and better over time. Now, that observe, act, evolve loop is perfect for a single agent. But let's be real. What happens when your organization scales up and suddenly you don't have one agent, you have dozens of them, all built by different teams? Well, you run smack into the next huge hurdle: interoperability. You've got all these amazing specialist agents, one for sales, one for support, but they're all stuck in their own little silos. They can't talk to each other, and that's incredibly inefficient. You end up with teams just rebuilding the same capabilities over and over again. The fix, of course, is a standard way for them to communicate. But here's the key thing to get. There are two different levels to this. There's a protocol for talking to simple tools, which is basically just saying, do this one specific thing for me. But then there's a protocol for agent-to-agent communication, and that's about delegation. That's about saying, hey, I need you to achieve this bigger, more complex goal. You know, the best way to understand this is with an analogy. Picture an AI-powered auto shop. A customer comes in and tells the shop manager agent their goal. My car is making a weird noise. That's a complex goal, so it's A to A. The manager then delegates to a mechanic agent, again, A to A. But when the mechanic uses a specific diagnostic tool, that's a simple command, so it's MCP. Then, when the mechanic needs to order parts from a supplier agent, we're back to high-level delegation, A to A. See how they work together? Okay, so let's pull all these pieces together. You have the pre-production quality gates, you have the in-production loop of observe, act, evolve, and you have the protocols for getting all your agents to work together. When you combine all of that, what you get is a whole new operational discipline. And that new discipline, that's what we call agent ops. It takes all the battle-tested ideas from things we already know, like DevOps and MLOps, but it rebuilds them for this totally new world of autonomous, interactive AI systems. It's a framework designed from the ground up for agents. The agent ops lifecycle is the whole picture. It's the map that takes you all the way from that initial, scrappy prototype through those automated quality gates into a safe production environment, and then fuels that continuous loop of evolution. This is how you finally bridge that huge gap between a cool idea and real business value. So here's the big takeaway. This isn't just about building smarter tech, it's about building the operational discipline to manage it safely and effectively. Because the next big thing isn't just about building one brilliant agent, it's about orchestrating a whole symphony of them. And the real question you have to ask is your organization ready for that?